So welcome to today's webinar. Our topic is optimizing AI strategies in the modern data landscape. I'm Steve Perchinuski. I'm on the product marketing team here at Vast, and I'm joined today by Dr. Carleen Tarto. She is our field CTO and head of strategy. Carleen, will you introduce yourself?
Hi, yeah, thanks, Steve. I'm Colleen Tarto. I am Field TCO and Head of Strategy for the Vast database, and I'm coming at you live today from Boston. I'm very excited to talk about AI and data and lots of good stuff.
Awesome. So we've been working this for a few weeks, and every time we talk, I learn something. So I'm just super excited for our audience. We're at this kind of really interesting inflection point where we're seeing the blending of business intelligence and AI. And we're focusing on structured data now with the promise of AI to unleash the untapped potential of unstructured data. So there's a lot of considerations to understand before we begin this journey. Colleen, you work with our customers every day to help them navigate this challenge. Do you want to jump into the agenda and kind of set the stage?
Sure. Yeah, I'm going to start by just sort of, like you said, setting the stage with the value of data and talking about where we are right now with the modern data landscape, because it's a huge market. And then we're going to talk a little bit about where we are with traditional analytics and BI, and then data maturity, and then how we take what we have and optimize it for the future of data, which includes AI, deep learning, LLMs, and who knows what else. So here we go.
Here's our poll. So it'd be great to understand the challenges that our audience is facing. So we're going to use a poll. So go ahead and answer this poll. And we want to understand what your biggest challenges are in optimizing your data pipelines. So Colleen, while people are answering this, is there any color you want to add to this? Like, what are our customers telling us is their pain point?
I mean, I think it's honestly a blend, which is why we're saying multiple choices allowed. Like some folks, if they're lucky enough, then the sky's the limit as far as cost, and their company is all in on data, but they're still struggling with security and privacy or scaling or taking what they have and scaling it out to an AI scale. So, and we're going to talk about all of this today, but I'm curious to see what the responses are.
Yeah, same here. I guess, kind of my assumption was, business intelligence is very regimented. They're used to these challenges, where in AI, it's probably kind of Wild West. It's like, it's performant and it's fast. And like now they've got to think about, the adult things like security and privacy and costs. I don't know. That's just kind of like my impression, but So we'll check out these results.
Looks like it's a blend of things.
It does. Yeah, it's about what we expected.
Yeah.
Awesome.
Interesting. All right. Well, let's start by talking about the value of data. And I always like to sort of set the stage by saying that data is a business product. And if you're a widget manufacturer, your main product is widgets, but then a side product is also your data about the widgets, about your consumers, about the market, things like that. And so really the name of the game for all of this is to harness the business value of your proprietary data. And it can be as simple as doing reporting, or could be as complex as running deep learning and monetizing your data, right? And so figuring out what that is for your business is really the goal here. And we've done this traditional analytics and BI for something like 40 years now, right? And then now everyone's trying to do AI for whatever definition of that they have. And so what we're really talking about is a blend of these things to really understand what can help your business in particular. Not all businesses need deep learning and extensive BI, right? And so some do and some don't. And so figuring out what's right for you is really the name of the game here.
Makes sense.
Yeah. And so the other thing I always like to point out is that data, the value of data is changing over time. When you first are selling something or you're transacting with a customer, that transaction, that single event has operational value, right? Like you take a single sale, you take the information about that sale and you put it into an invoice, you put it into a database. That's a single event's value. And it has a lot of value at first. And then very quickly, nobody cares about that single event. The invoice gets paid and nobody thinks about it again. However, the value of data as it ages becomes different. It's more valuable in the aggregate. So that single event as part of an invoice, as part of a customer pattern, as part of a region, as part of an overall sales goal, that's more interesting. And then even more, you want to use that event to predict, to prescribe how your business is running in the long term. And so that's where things like deep learning and machine learning come in. And that's why keeping your data around is very important. As recently as just, well, today, but a few years ago, people were sunsetting data. They were shipping data off to cold storage after a while because it was too expensive to keep it around. But then the problem becomes, how do they use that data in the aggregate? They have to pre-aggregate it. They have to bring it back from cold storage, and that's a huge problem. And so luckily these days that's no longer necessary, because folks are realizing that that data does have value when it is all together. So the other thing to think about is, what does your data look like? Is it structured? Is it, like I said, a transaction invoice? Is it like a name and, columns and rows and things like that? Or is it audio, video, pictures, other things that are unstructured? So it turns out that structured data is only about 5% of the data that we produce. And remember that, every year these numbers go up literally exponentially. And so something like 95% of the data that the world produces is actually unstructured. These are things like this webinar video, where it is completely unstructured. Hopefully Steve and I have a little structure, but our mission here is to really activate all of this data. We have a really good handle on structured data because it's rows and columns. People can think of it as a spreadsheet, and that's great. But it's the unstructured data that has a lot of the business value. And so our mission here, both at VAST and as a society, is to really activate this data to get the value out of it and to extract business value from that data. And so that's really what we're looking to do here, is to not just treat structured data over here and unstructured data over there, but to really harness the value of both of them together and to understand how they play off of each other. Because if you think about it, structured data, a lot of people call it semi-structured data, it has metadata associated with it, which is often structured. So both unstructured and structured are related to each other. And when you're processing unstructured, you might generate structured data. When you're processing structured data, it might reference unstructured data. It's really an entire ecosystem of the entire set of your data. So the modern data landscape. And I know that modern has a lot of different meanings these days. There's things called the modern data stack, and we think about these things a lot. But stepping back, it really is all about getting insights out of data, right? And so your data is produced at some source, and then you have a pipeline to get it to the consumption layer. So you've got data, you're producing widgets, and your widget producing machines are sending you data about how they're producing those widgets. And then you have some analysts down the line. How does data get from that source to that analyst, right? So this data pipeline really can be broken down into these 4 basic steps, although of course they're much more complex in real life. So you have the data source, which is where their data gets produced. And then you typically replicate it into some ingestion layer where you can then curate it, meaning you can transform it. You can do something as simple as changing the format of a column, or, shortening a video, or standardizing things. But you can also do things like define what a customer means, right? This is kind of a joke, but defining what a customer means is literally one of the hardest things you can do with data, because it's always like, well, does it mean active? Does it mean inactive? Does it mean somebody's actually purchased or just visited the website? Things like that. And so curation is actually a very complicated step. And this is the bulk of where the business value is applied. And so then you've got the consumption layer. Once you've got that data curated, you've got that consumption layer where you're actually doing your AI, your BI, your analytics, and you're producing business value out of the data at that point.
Nice.
Yeah. So this pipeline has changed over the years. It's been around for 40 or 50 years at this point. And in the 1990s, when I started doing this, it was all about ETL and enterprise data warehouses. And, there were a few DBMS's, database management systems, that were on the market, and everybody talked about things like OLAP cubes. OLAP means online analytical processing. So the fact that they felt they had to put online into that tells you about where we were. And things like third normalization form of your data warehouse, making sure all of your data was perfectly modeled. And this is the kind of thing people were thinking about, was just harnessing what the data was in the first place, right? Like they couldn't even think about the curation layer. They just had to like understand where the data was and what it was. In the 2000s, this evolved into the world of data warehouses. We started thinking about things like data quality and data governance. And this was the onset of tools like Hadoop. And things matured. And then we had this thing called the cloud come along, and infrastructure became less of a problem. And that was really exciting. And then we had SaaS services, which was even more exciting. And people started thinking, well, I really want to focus on the curation layer, but I only want to focus where I really need to. And so they started throwing all of the data into a data lake and doing schema on read rather than schema on write. So rather than warehousing your data and putting it into a model before it's consumed, they moved the curation and the definition of the model to later in the pipeline. And then we got things like cloud data warehouses. And then around, I think it was like 2012, when everyone wanted to hire a data scientist. And data science was the sexiest job of the century or whatever it was. And everybody wanted to do machine learning. And then people kept struggling with that because their data wasn't in a good enough spot for that. And so fast forward to the 2020s, like, 4 years ago, we had the explosion of the modern data stack. And I'll talk about that in just a minute, but we started focusing on things like composability of the stack and really just thinking through what your business needed and picking and choosing the tools that built the pipeline that worked for you. And there were things like data observability, lake houses, which marries data lake and a data warehouse. Generative AI, DL, deep learning, and LLMs have become popular. Everybody's using ChatGPT. We may have used ChatGPT to write this entire talk. We didn't, but we could have. And then the idea of data products. And that came out of a data management paradigm called data mesh. And the idea of data as an actual product with product managers, with planning, with development around it, like data products has been really revolutionary in this market. And so then here we are where everyone is trying to do AI. So what does that mean? Well, we're going to get to that. But first, I just want to talk about the market opportunity. As you can see, things have changed a lot. And this is sort of in a year over year picture snapshot of the CAGR in the data analytics market. And in 2021, it was 31.8 billion. Now, in 2030, we're going to be up to 400 billion, which is kind of ridiculous. And data is growing exponentially. I don't need to tell you that. That's been true for a while. But every customer, every single organization is on this journey to access all of their data. And so Vast has been focusing on storage of that data. And then what are you doing with that data beyond storage? So things like BI and AI. Yeah. So, what was that?
I was just saying it makes sense, right?
Yeah.
That massive opportunity, a lot of people are going to be in this space.
Yeah. Oh, absolutely. And I always like to show this because in 2012, a guy named Matt Turk and Siobhan Zillis, they put together this picture of the big data landscape, and they sort of broke all the vendors and data out into different categories and put them all together in this picture. And it was very cool looking at all the vendors. Today, this is what it looks like. This is from 2023. Yeah, it's a lot. It's a lot.
That's an eye chart. And I assume that Vast is somewhere on this as well, right?
Well, and I've worked at several companies and I usually can't find them on here because we do get smushed down into one category. We're actually in the top left. Vast is sort of up in that corner under storage. But again, we do more than storage, but they just put us in that bucket. And so what's interesting, though, is just thinking through the massive opportunity here, but also the almost over complexity of the entire market, right? Like there's so many tools for every single piece of this composable data stack, but it's almost paralysis by choice, right? Like there's just too much choice. And if I'm like, hey, you need to do analytics, like where do you even start? Let alone the AI ecosystem, which changes daily, it seems. So there's a lot here and it's confusing. So what we're going to do today is sort of, not walk through this, but we're going to talk to different pieces of this and sort of how it fits together, and then how to build a data stack that can take you not just to BI, but to AI and hopefully beyond.
Perfect.
Yeah. So let's start by talking about that BI, though, the traditional analytics. So I like to think about this. What does a SQL query cost? So say I'm an analyst and I have to run a SQL query and I want to, count the number of customers in my database. And I'm in a BI tool. So that query comes from a database. That database is pipelining data from some curation layer. That curation layer pulls it from some ingestion layer, which comes back from the source, but it's joining sources. There's all sorts of pipelines in there. People built those pipelines. There's infrastructure that they're running on, either cloud or on-prem. And if you think about it, you've got all these different cost centers inherent in a single SQL query. You've got data acquisition, storage, infrastructure, people, consumption. You've also got latency. Every time you copy your data and every time you add something to a pipeline, you're potentially adding in latency. So if I run a query and I say, how many customers are there? But customers have been added since I started this pipeline, I won't be capturing them, right? And a lot of times you end up with these batch pipelines that run once a day. And so you're always stale. And so that's really challenging because the more complex your pipeline, the more latency, the more risk, the less resiliency, all of this. And so when you think about this, the more money you're sinking into your data infrastructure, the higher the cost per query or the cost per insight. So, every time you run a dashboard, there's cost inherent in that. And so the more money you're sinking into your data infrastructure, the higher that cost and the less overall value that you're getting from your data.
So it really impacts your ROI.
Yep, exactly. Exactly.
Yeah.
And so data infrastructure costs are just growing exponentially as we add more tools in and we add more use cases to the end because we're adding more insights that we want to get out of the data. And so that data ecosystem complexity is actually outpacing the value that you're getting from the data. And in the end, what happens is that your data program can actually suffer or fail. Now, there's a lot to that, but I want to just step back and talk about data consumption because I just talked about a SQL query, like a single SQL query. But in reality, what people are doing is more complex than that, typically. You end up with things like BI, so reporting, monitoring, data warehousing in SQL, like, people are just doing exploratory queries. And that also gets into machine learning and Python. But then visual analytics and dashboards, a lot of places have like executive dashboards that are refreshed periodically, that kind of thing. And then, that same data stack that you've built to handle those BI use cases can often be used for machine learning and Python. It can be extended to that. But the difference is that when you start talking about deep learning and accessing your unstructured data, you struggle because that's a different use case and it's a very different scale, the very different performance considerations, and that's where the costs tend to really go out of control.
So
And they
scale
really,
is kind of the big factor that's really going to drive
yeah,
costs through the roof.
yep,
Okay.
yep. Because remember, 95% of your data is unstructured.
Right.
So if you're only talking about structured data, sure, you can build a little BI stack and that's great, and it handles your, few terabytes of data. But when you're talking about petabytes, that's a different ballpark. And so I also added et cetera here because I don't know where we're going to be in 10 years.
Right.
Sorry. I don't know where we're going to be in 10 years. And, you want a system, obviously like vast, we're going to say, but you do want a system that can handle both AI and BI because you want something where you don't have to pipe your data around for all of these different end use cases for these consumption.
Right. And I do think that et cetera part is what kind of scares people because
Yeah.
they've seen how fast things have changed in a couple of years. So it's
Yeah.
scary to think you might make a decision that will paint yourself in a corner going forward. So yeah, that's a
Absolutely.
great point.
Yeah, absolutely. So the way this is typically done, however, is to have an operational stack. And this is your transactions. This is where they come in and you've got structured data, unstructured data. You've got some compute layer, some data processing that happens on top of it. And then you've got your operational applications. You can think of this as your transaction stack where you're like building out invoices based on transactions, right? And that's been around forever. That is typically sacrosanct. We don't touch that.
Mhm.
So what you do is you pipe your data, your structured data, over to a BI stack, which again is going to be structured data plus compute, some curation layer, and some application layers. Now, it's 2024. Literally every board ever is saying, hey, let's do AI, for whatever that means. And so what happens is you end up needing to build an AI stack, which is somewhere in between the two, right? It's got structured and unstructured data. It's got some compute, and then you're training and inferring based on your data, and you need new data as it comes in, and then you've got AI applications. So the question is, do you have 3 stacks? And in reality, it's a lot more than 3 typically. And then what do you do when you need to move data around? You end up with these pipelines, and it's a spaghetti mess of data moving around. And again, that's going to cause latency issues. It's going to cause resiliency problems. It's going to be fragile, and it's going to be overly complex. And the people costs are exponential as well. If you need people to keep this up, that's pretty complicated. And remember that this isn't a direct revenue center either. This is your data, which doesn't necessarily actually impact direct revenue, depending on what your business model is. So this can be a real struggle for people.
Yeah, especially if this is what you're relying on to make decisions, right? I think,
Yeah.
every phase adds latency. It causes a lot of concern about where's the source of truth.
Yep.
Am I getting the best data for my decision? That can be
Yeah.
unnerving.
And data drift is a real problem. And also, like, data literacy is a problem. And people don't know how to use the AI or B applications. And then people don't know what data is out there. I mean, I've worked at a lot of companies running data where people, we've built a data dictionary because people don't know what the data means. They don't know that when I say customer, I mean this. When you say customer, you mean that. And so we call it something else. And so there's a lot to it, and it's incredibly complicated. So the message here is that the more you can simplify this, the better. And if you have 3 completely disparate data stacks here, you're going to run into trouble because you're moving data from one to the other, and they need to talk to each other, and you're pipelining data from one to the other. And ideally, you want to rethink things, and you want to rethink the complexity that you've got here and try to simplify it as much as possible. So that brings us to our next point, which is data maturity. And this is something I've been thinking about for a few years now, because data maturity is not about how much data you have or how big a company you are. You could be the biggest company in the world and have no idea what data you have, or you could be a small company that's really got a handle on its data. So going back to the BI use cases, the simplest use case, again, we have structured data storage, we've got some compute and BI applications and BI data curation. This is the kind of thing where there are a million tools for doing all these different steps. And you can literally just you could probably pick one out of every category and you'd probably be okay to start. But if you think back to that data landscape diagram, there are a lot of choices you have to make. And so the thing that you want to think about is the business application in the end. What do you need? Right. And so in a BI use case, it might be executive dashboards, it might be alerting and monitoring of sales, that kind of thing. And so you need to think about that. But you really want to think about it in terms of hindsight, insight, and foresight. And so the way I think about this is you've got sort of the value of data on the x-axis, right? So low value at the bottom, high value at the top. And then you've got what's easy and what's hard. So looking backwards at what happened, like reporting, it's pretty easy, right? It's also not super valuable. I mean, it's good for like reporting and, SEC filings and things like that, but it's not the juicy stuff, right? A little harder and a little more data, and you can do some really interesting things. You can start to think about insights into your business. Like, what are our customers thinking? What are they doing? What do we think is coming next? And then the hardest thing to do that also has the highest value is the foresight. What's coming next? How can we not only predict what's coming next, but prescribe what happens next? Right? So predictive and prescriptive analytics and using AI to drive that is what's interesting. So that's one way of looking at data maturity. Let's do a poll.
Yeah, I was thinking, let's ask people where they are on their kind of data journey. So again, like you said, there could be small organizations that are very mature from a data aspect and large ones that are not. And I guess maybe even being small could have some advantages because you've got a better grasp around what's going on.
That's true.
So
you probably don't have as much data, so maybe you can't do the prescriptive analytics yet.
Right.
Kind of depends what you're doing.
So take a second, jump in here. We're curious to see where you are, and we will take a look at these. And again, it's going to vary greatly. So we'll give just a few seconds for that to go up, and I'll also take a drink during this brief pause. Great. So about where you expected things to be, and again, if we look at our audience, we've probably got a pretty data-centric group, so you would expect them to be, a little more toward the mature side. So
yeah, and this is interesting because the other question is, where would you have put yourself on this 2, 5, 10 years ago? Where will you put yourself on this a year from now, 5 years from now? Right. And I think it does change and ebb and flow depending on what the use cases are. Because if you're not thinking about AI, maybe you're doing great. But if all of a sudden I throw a new use case of, LLMs in here, maybe you're not great. Right. So it kind of it changes over time. But that said, that's sort of the evolution we've seen in the market as well. Right. So again, if you think about low value, high value, that's one thing. But now I'm talking about structured data, unstructured data, and data volumes on the x-axis. So if you think about structured data, small data volumes, that's reporting, right? That's typically reporting some BI. If you throw in a little bit more data and maybe start thinking about unstructured data or semi-structured data, that's BI and data science. But when you get to really large data volumes of unstructured data, that's where AI is. And again, that can also be the highest value you can get out of your data. So the point that I started to make earlier,
this is the challenge, right? Yeah.
This is the challenge is that what got you here to a BI and data science ecosystem. And when I say that, I mean your infrastructure, your tooling, your vendors, your partners, and even your people. What got you to a BI and data science success point won't necessarily get you to AI, right? Like it's a whole new can of worms and it's a lot more complex. I mean, this chart probably should be steeper, right? Because the AI, the data volumes we're talking about, the problems that we're talking about solving, I mean, it's incredibly complex. There's a lot of academic research happening here because it is new to everyone. So what got you to BI won't get you to AI. And that's something you need to think about as you start thinking about the future of your data program. And I hate the statistic, but I love the statistic.
Yeah.
85% of data science projects fail. And I hate the statistic because I, don't want to see a data science project fail and it's depressing. But on the other hand, that means there's a lot of opportunity here. Right. And it means that we are experiencing that what got us here won't get us there, right? Like data science is the hard part. And a lot of this is challenging because the data is not in the state we need it to be. There's too many pipelines. It's too complex. People don't understand the data. The data is not clean. In order to do data science and AI, your data has to be fairly clean and well understood. And that's not always the case. And so a lot of that 15% is probably focused on structured data, right? The successful projects. Right. But I guess that the 85% is doing more complex things. And so this on that data maturity curve, these are the mature projects, right? These are the mature things that we're trying to do that are failing. And so I'd love to see this number go down. I don't know when this number's from, but I'd love to see it go down. So
same.
We should flip it around and say 15% of data science projects are successful.
That's our goal.
It's more positive. So again, just recapping what the data challenges are. We've got too many pipelines. They're too complex. Data is growing, so those pipelines are breaking. I mean, I've worked at places where we literally had a pipeline monitor that every morning would send a thumbs up if it succeeded and a thumbs down if it didn't. And it's just, that's rough. And that was a very small startup. So, the data stacks that we've built to focus on structured data aren't going to be able to handle unstructured data and the problems of the future. And you've got millions of vendors and tools requiring all this management, even if they're in the cloud and even if they're SaaS, they're just still challenging. And it's a cognitive overload problem, right? Like your data engineers are struggling to handle all of this. Your data leaders are struggling to come up with a strategy because there's too much choice in a lot of ways. And then that, of course, leads to governance being too challenging, because when you have all those pipelines, it's very hard to govern that, right? And then on top of that, you've just got like this complexity of the data ecosystem. But all of this adds up to give lower ROI on your data because the TCO is higher, the value that you're getting out of your data is lower. And so this is something that we want to solve. We want to help solve this. So, in other words, let's break it down even simpler. You've got complexity, exponential cost, decreasing performance, and then challenges with security leading to lower ROI. And that's just really not great. So let's fix it.
Yeah, it's pretty daunting.
Yeah. And so the two things that I like to focus on are the fact that we need to build a data ecosystem that can handle both small to medium scale, but also scale out to handle larger data sets. Because, the hope is that your company grows. You don't want to stay a small to medium scale company. You want to grow. And so building something that can start small and grow into what you need it to be 1 to 5 years from now, 10 years from now, and then we also need to be able to harness the composability of the stack so that we can use whatever new generation of tools that we're doing. Right now, it's all deep learning, right? We want to be able to focus on that unstructured data. I don't know what it'll be in 5 years. And so I want to build a stack that will be able to handle this new generation of tools, but also whatever's next.
So as it exists today, are there like essentially separate teams that are running each of these stacks? And then you kind of need to see a convergence going forward, or is it really?
Yeah.
Okay.
It could be. Kind of depends on the company, right? Like a smaller company, it might be the same team. A bigger company, it might be completely different groups. The thing that you need to think about is mostly the business focus, the business use case. So like, what are we actually trying to get out of the data? Is it well-structured problem, or is it that we're still in an exploratory phase and we're just trying to build something that will get us wherever we end up deciding we want to go, right? Which I think is where a lot of companies are in AI right now. They're like, we're going to do AI. And it's like, what does that mean? Well, we'll figure it out. Does it mean you use ChatGPT for your customer support chatbot? Or does it mean that you're actually like feeding value back into your system with LLMs or with deep learning? So we've gone through all of that sort of backwards looking. How do we build a data ecosystem for this future of data, both the future that we can see in the next year or so, and then what might be coming next after that? Well, I like to go back to the basics. I like to think back at the pipeline, right? The point is to take your data from the source and get it to some consumer in a data product that they can use that will make the business better, right? Whether that's somebody getting the right dashboard, whether it's actually using AI to feed something back into the process so that the data produced will actually feed the data being produced in the future, that kind of thing. And so, how do we do that? Well, remember, we have a structured data pipeline, and we've talked about that, and that's the BI sort of use case. And it's more than just the BI use case, but it's really like, what are you thinking about your structured data? And this is very database driven typically. And then you also have an unstructured data pipeline, and perhaps never the twain shall meet, but maybe the twain shall meet. And so really like you have to ingest, curate, and consume both of these separately. And so the question is, how do you do that together on the same platform? So I want to pause for a second because I do want to ask this question. Another poll.
Yeah. So we do want to understand how you're using unstructured data today. And again, this is going to be one where you can only pick one, right? Not a multiple choice. So either A, you don't have any unstructured data. B, it's, you've got it, but you just haven't figured out what to do with it. Or C, it's already a key part of your data strategy. Yeah. So again, curious on this one to see, because I kind of feel like, who needs the most help here, right? It's probably the B and C. If you're solidly an A, this probably isn't all interesting. You're probably not on this
Yeah.
webinar. So
Yeah. But that's also, there's shades of gray between those two. So I'm
true.
curious to see where people land.
All right. So
All right.
what do you think
Interesting.
about that? I mean, yeah,
Interesting. All over the map there.
a bit more than I expected.
Okay. So when we think about the AI data ecosystem, again, we want both structured and unstructured data to be able to be handled here. So structured data, traditionally, we've had the OLTP use case, the transactional use case, and the analytical or OLAP use case. And you can have multiple databases to handle those. You can have one, you can do it in a bunch of different ways, but that's sort of the data that you're accessing via SQL. You're ingesting streams, you're using compute engines like Spark or Trino on those. And that's sort of the known world of structured data. And then the unstructured data world, we've got like multiple protocols you can access it with, whether it's NFS, SMB, S3. And that's where you really need something scalable, right? Because that's the thing, that's the side of the house where you're doing your high performance computing, you've got your file and object infrastructure, but you need it to be able to scale, because remember, that's 95% of the world's data is unstructured. And then keep in mind that you want these two things to inform each other, right? So you want your structured data and unstructured data. The whole point here is to get them on the same platform so that they can actually inform each other and serve each other. So you need these like functions to go in between them. And then on top of that, you want to have like one entire environment or namespace where, whether data is coming in at the edge, whether you've got your core infrastructure, or whether you're even in the cloud, you can still refer to your data and it's all part of one ecosystem. Now, this is where I think we're going, as a data society. Because I do think that when you start talking about AI, this is what you have to do. There is structured data in AI as well. And so you need to be able to access both of these in the same landscape. And so, for example, the vast database is a transactional and analytical database that can handle your structured data on the same platform as the vast data store, which is a multi-protocol data store for your unstructured data. And then we have a data engine, which actually allows you to run these functions and triggers between the two as they're ingested or after they're ingested. And then we also have our vast data catalog and our namespace and all these wonderful products that we have that target this sort of ecosystem. But this is really all about creating something that can harness the power of all of your data, not just structured, not just unstructured, but in the same environment, so that you're minimizing the complexity of the environment. Because remember, that was the name of the game, was to streamline the pipelines.
Because the traditional approach would be to have like one separate animal for each of these functions,
Yeah.
which then has to be all pipelined together. This gives
Yeah.
you one unified view because it's all in one place.
Yeah. And then when they're
Powerful.
siloed like that, it's going to be a struggle or an insurmountable challenge when you do have something that you need both of these things, right? When you need both structured and unstructured data. And the other thing to think about when I say scalable, I'm not kidding.
Right.
When you think about AI pipelines, you're talking about tens of petabytes of data, if not more. I mean, we've got customers that are going out to exabyte scale. And that's the raw data. And then you refine it and, you might take it down by a factor of 10 or 100. And then you're sort of running your AI training, and that's where your GPUs come in, and you're doing things like model training and inference based on your training. And then you can, sort of get the business value out of those models. And at that point, you're typically down to a much smaller scale, but then you're going back to your original raw data sets, right? To take those inference results and feed them back into the pipeline. And then you've got things like audit logging and tracing. And so you need to think about all these different scales when you're doing AI. And so that's an interesting question. So when I say scalable, I mean, not only can it operate at a performance that makes sense for the cost that you're looking for, because you can make anything run as fast as you need it if you're willing to throw money at it. But you need to sort of balance that holy trinity of cost, efficiency, scalability, and performance. And so you'll note that there's many different scales here that you need to think
Right.
through. Like, what is the performance? And we've got both CPUs and GPUs, right? But then you've also got the performance of your storage and of your databases and all of that. So you sort of need to think through that at every step of the way.
Makes a lot of sense.
Yeah. So when it comes to building that sort of future-proof data stack, there's a lot of things to consider. And I'll go through these. So, like I said, scalability. You need to be able to scale, but then you also need to say, well, what if my company buys another company because we want their data, right? Like, can I just throw more storage and compute at this, or do I need to once again rebuild my stack? You don't want to do that. And so, making sure that you can scale and tune your environment to accommodate situations like that is really important. So it needs to be, tunable performance and tunable storage and compute at each scale. And then on the flip side of that, you also want to be able to add in the tools that you need. So it's not just storage and databases and compute stacks and things like that. Like, there's other things that you're going to need. And, we saw that Matt Turk diagram that was,
Right.
a huge data landscape. And so there's definitely tools that you're going to need at all levels. And so you want it to be a composable data stack. And so you need something that's going to have, partnerships and, common access patterns that you're used to. So APIs, SDKs, all that good stuff. And then you also want something that can ingest both transaction and events, right? Because you want to be able to do real time if possible. And then you need, the features, the good stuff, right? The UIs, all that good stuff that you're used to for both structured and unstructured. And then last but not least, probably most important, is the archive economics. You want everything to be operational at the scale that you need and at the performance that you need, but you can't just be throwing money at the problem, right? Because remember, data is not a revenue center everywhere. And so you need to make sure that you are focusing on cost efficiency. So you don't want to have to sacrifice performance or scale for the sake of economics. And so that's why you want something like VAST, where you've got the all flash archive economics across the board.
Yeah, this really predictable costs are important because things change radically. All of a sudden, you can't afford to keep the data forever. That's a huge part. The multi-protocol is also, I think, really important too. Just in terms of future-proof, like, you don't know what your next tool will want to use, so the ability to get your data over any protocol, I think, is really important.
Yeah, absolutely, totally agree. So, there's sort of a recipe here that I've hinted at, which is that you need to think about hyperscaling your performance and your scale. Hyperscaling your scale, because you need to be able to scale up and scale down as needed. Hopefully just scaling up, but you never know. And so you need to be able to perform at all of those scales, but then you also need to think about your efficiencies, your cost effectiveness. I spoke earlier about cognitive overload for your engineers. I mean, for all the data engineers here, like, building pipelines is hard, right? There's a lot of tools out there that help you do it better, but it's engineering and it's challenging, and being able to efficiently build a less complex stack and a less complex data pipeline is really important. And it's not just from a cost and perspective and scale lens, but it's also through an operational efficiency and maintenance lens. So, and that's really where
is key.
Yeah, and so that's where VAST is targeting in the middle. So, and so, yeah, we think about this a lot. We think about, you can kind of move these around depending on where you want them in the stack. But, a data platform, we talk a lot about data platforms. And this is one of those words, like, there's a few words, the engine platform, that have been around forever, and they've come to mean anything over time, right? When I'm talking about a data platform like VAST, what I'm really talking about is a storage layer, a data layer, and a compute layer. And really just like handling the core of the data infrastructure. And obviously, again, making it composable so that you can add things in as you need to based on your own use cases. That's where it's important too. You don't just want a monolith, You don't want some company that's like, we do everything from soup to nuts, because you want to be able to tailor it to your own ecosystem as much as you need to.
Yeah, that makes sense. There's a lot of companies that are like, positioning themselves as data platform, but they only kind of really do one of these slices. And in a lot of ways, it's like, that's fine if you're building your own data platform, but if you want to have one that's simple to manage, I think you're hitting on all the key points here.
Yeah, absolutely. So the vast data platform, to use that term again, what we mean when we say data platform is that we're really trying to create compute, storage, and data layers for all use cases. And so again, we have the vast database, which focuses on structured data, right? It's a table format, it's an engine that is allowing you to really store and query your structured data with best in class speeds. It's scalable. It's all flash archive economics, and so it's really hitting those three top points that we want there. But then it's also an operational efficiency because it's on the same platform as your unstructured data. And so the data store is where we would house our unstructured data. And that's that multi-protocol environment where you can sort of access that data however you need to, but it's linked to the database. And then again, we also catalog it. So we actually use the database to store the metadata about the data store. So you can actually, from an administrative point of view, understand your unstructured data very well. And then we've got a compute layer on top of that, which coming later this year, we have a data engine, which allows all those functions and triggers so that as you ingest, you can run functions on your data. You can, query the data as it's coming in and really understand your data from the beginning, which is important. And then we also have the ability from there with that same engine to feed up into the different platforms, like for operational data processing, for BI, for your data curation, and for your AI training environments. So again, reducing the number of pipelines and reducing the TCO for data so that your ROI for data is going up.
That makes sense. Yeah, trying to build this all on your own would be extremely complex.
Yeah.
And here we're kind of giving you, a stack that's easy to support. Makes sense.
Yeah. Yeah. And the stack that actually handles all three of those use cases, those broad use cases, is really important. So this gets back to my comments earlier about data maturity. The point is, how do you get more value from your data without increasing the TCO? Because if you did just have an existing BI stack and you decide to add in an AI stack, that's going to be challenging because, you're going to have to build something completely orthogonal to your original stack. And that's going to be, the infrastructure costs alone will be astronomical. So.
Yeah, going back to that one quote about how many projects fail, you've got to think that cost becomes a major, even if they're doing something really interesting, right? Yeah. If it's just not returning value, then it's not going to succeed. And this kind of helps there.
Absolutely. And that's the value of a data program, right? Is a solid data strategy that gets you to the future and even beyond what we currently know as a use case. You don't want to boil the ocean, but you want to make sure that it's scalable beyond where you are today.
Yeah, I think that goes a long way talking about future-proofness. So, boom, next slide, future-proof.
Yeah, there you go. So future-proofing is really important. And again, future-proofing, but with the archive economics, right? That's what you want. You want something scalable, performant, and cheap. So
exactly.
Good.
All the Trinity.
Yeah. So that's really, how we propose to get that increased ROI on data. And that's really the name of the game in my mind, is getting all of the value you can out of data, squeezing that sponge as much as you can, but making sure that you're not just throwing money away.
Right.
During that process. So, yeah. And and if you're ready to learn more, Steve, you can talk about this.
Yeah, so we actually, you can download this report. If you click on attach, the attachments tab, and click on download. So this is by Sumit Pal. He is a former VP at Gartner, and he did an analysis of the vast data platform. So a lot of the points that Colleen hit on today, he went through and analyzed, took a good look at this platform. So it's a really valuable tool. And we encourage you, if you also want to learn more, visit us at vastdata.com. And Colleen, I just want to thank you for your time today. I mean, every time we talk, I learned something new. So I know our audience did as well. And again, thank you for your time today. Please reach out. I think it's, kind of like, taking that first step, like, looking at your data, understanding what you have, and then kind of looking forward is I think the first thing that people need to do. But yeah, thank you so much, Colleen.
Yeah, thanks, Steve. It's been great.
It was fun.
Cool.
All right. Well, thank you so much. Again, please reach out, and we appreciate your time. Take care, everyone.
Thanks.